Now, for chapter 3, we have what we call single statistical inference for single population and also two population. Okay, and what we have done last time, we have discussed theoretically on how we can perform the hypothesis testing, and it could be performed using three methods. Okay, so let us look at the several concepts that we have discussed last time. Okay, so as I mentioned earlier, hypothesis testing for single mean is actually a type of statistical inference that we are doing for our population, okay, referring to our population, but using our sample. So knowing that we have our targeted population and knowing that we have limited time, limited budget, and limited human resource, so what we do, we select our sample, and from that sample, we wish to collect our sample, and we do some measurement, and we do some what we call data gathering, data summarization, analysis, and everything. And at the end of the process, we are going to do some statistical inference using what we call the sample mean and sample proportion, and that will be used to what we call make decision or making inference for our population mean and population proportion. And this process from sample, okay, to back to the population is what we call the statistical inference. Okay, and this statistical inference is using the evidence of our sample. Okay, so that would be the whole idea of statistical inference. Now, last time we have discussed what is hypothesis testing, and in our hypothesis testing, there will be two statements that we will always refer to, and that will be our decision-making standpoint. Okay, and that two statement will be the null hypothesis and the alternative hypothesis. And in terms of notation, null hypothesis is known as H null, and alternative hypothesis is H1. Okay, what is null statement? What is alternative statement? Okay, if let's say your claim is defined at the null statement, okay, a claim assumed to be true until sample evidence indicate otherwise. So if your claim is at the null of statement, so we wish to gather the sample evidence to what we call support our claim. And if we do not have sufficient evidence, then only we will reject our null hypothesis. For the alternative hypothesis, okay, alternative hypothesis is a claim to be supported based on sample evidence. So we will see later how these two statements become what we call a decision that you need to make. Okay, and for the hypothesis testing, it will involve three types of tests. Okay, so the first one would be two-tailed test. Second one is what we call right tail test, that will be one tail test, and the second one for one tail test is what we call the left tail test. Okay, so if we were to draw how what we call the description of two tail test and one tail test in terms of the Z standard normal that we have discussed before. So we are talking, if it is referring to tail test, it will be referring to the alpha over 2, that will be for the rejection region. And for the right tail test, it will be in the upper tail, so that will be referring for alpha. And the other one will be left tail test, where the rejection region will be at the left hand side of the distribution. And how does the statement look like in terms of the notation? You will have null statement, mu is equal to mu naught, alternative is mu naught equal to mu naught. So what is mu naught? Mu naught is the value that we are testing, and this value refers to the mean of the population. We have two types. Okay, for the first one, it will be the mean, which is what we are discussing right now, and the second one would be the proportion, population proportion. Now, if let's say this is two-tailed test, okay, so this is how it's look like in terms of the notation of your statements of your hypothesis. If we have right tail test, what happens is that you will have your what we call indication is at the what we call alternative statement. The same goes to the left tail test. Your statement that refers to your what we call left or right will be at the alternative statement. And if you what we call if you realize, okay, your now statement will always be the same for whichever of your test, whether you have one tail test, right or left, okay, or you have two tail tests, the now statement will always the same. Mu naught, mu is equal to mu naught. Okay, the rest of your alternative statement is the one that reflects to your two tail or one tail. Okay, so that would be in terms of notation. But somehow, some researcher likes to what we call write them in terms of words. Okay, so you can have also your statements in terms of word, for example, as this one. Okay, the population mean is equal to mu naught. Is equal to, so it refers to the noun statement. Not equal to is the reverse, the alternative one, which reflects your two-tail test. And if you have right tail or left tail, okay, so you will have this kind of what we call hypothesis statement. Okay, so remember the mu naught will always equals to the hypothesized population mean, which are invested in your analysis. Okay, what about proportion? Almost the same as what you have in population mean, except that the notation would be referring to the proportion of your population. So remember, it will always reflect the population because this is the one that we are trying to infer using the sample evidence. Okay, using the sample evidence. Okay, so that's why we are using our X bar and P hat to make decision for our population proportion and population mean. Okay, very quick on the concept. Okay, so how many types of method that can be used to perform the hypothesis testing? We have three types of method. First one is the traditional method. Second one is the p-value method. And the third one is confidence interval method. Okay, so the confidence interval methods, I will reserve that until we have discussed the traditional method and the p-value method. Now, what is what will be the step when you are using your traditional method? Okay, so for the traditional method, there will be 5 steps involved. The first one is identify the claim of unknown parameter of interest and state the hypothesis statement. So in this case, you need to figure out what will be your noun, what will be your alternative, and that hypothesis testing is referring to what? Whether it is referring to the mu or referring to your P, population proportion. And you need to identify which one of your statement would be your claim. Is your noun will be your claim or your alternative statement will be your claim. Okay. Why do we need to identify which one of the statement become the claim is because the way we make the decision at the last step, it will be very helpful if you can identify which of your statement become your claim. Now, that would be the first step. The second step would be finding the critical value. Last time when we discussed about what we call CI, okay, we also discussed about critical value. That is defined by your alpha. Okay, defined by alpha. We may have two types of alpha, whether it will be alpha or it will be alpha over 2, which reflect your two-tail test, okay, or one-tail test. Okay, so again, it reflects the what we call the upper tail or the lower tail of your distribution of your Z standard normal. So it's either both of this area or either one of the area. Okay, so that will be the critical value. And where is the critical value? Of course, at the Z alpha over 2 or Z alpha over 2 or either one of the alpha. For example, if it is one tail test, then this will be your Z alpha. Okay, or if it is left tail test, and this will be your negative Z alpha over 2. That would be your critical value. Okay, so what will be your Z alpha over 2 or Z alpha value? Now, the third one, compute your test statistic, and that would be involving some calculation with reflect to your Z or to your T. It depends on the number of sample size that you have in your investigation or based on this known or unknown sigma, as long it refers to your what we call hypothesis testing for population mean. If you are dealing with population proportion, then you will always using your Z of your test statistic. And the fourth step will be making decision, okay, whether you will reject the null hypothesis or you will fail to reject the null hypothesis. Okay, so we will see how we can use information from the second step and from the third step in order to make decision in the fourth step. Okay, and finally, once you know that you will reject or you fail to reject the null hypothesis, then only you will make your conclusion at the end of your process. Now, I'm not going to repeat this again except for this one. Okay, for this particular thing, okay, this will involve in your hypothesis testing for the population mean. Okay, that will be your mean. Why? Because there will be condition where your sigma is known or unknown. If it is known, then you are using your population standard deviation in your calculation of your test statistic. Okay, your test statistic is your Z. If it is unknown, okay, so you will have to look at the sample size of your experiment or investigation. What is the sample size? If the sample size is larger than 30, then your standard deviation will be estimated using the sample standard deviation. If your what we call sample size is smaller than 30, so what happens is that you are no longer using your standard normal, but you are using your p-distribution. Okay, as I mentioned before, p-distribution is still normal, but it is what we call kind of one type of standard normal distribution of data. Okay, so again, the standard deviation will be using your sample standard deviation. Now, please remember this step because this only involve when you are dealing with population mean, but not for population proportion. Now, let us look at the first example. Okay, last time I did manage to discuss until step 4 if I'm not mistaken. So if you look at the textbook on page 87, okay, page 87. Now, a sample of 50 internet shoppers was asked how much they spend per year on the internet. From this sample, mean expenses per year on the internet is 1,300 and the sample standard deviation is RM 1,100. Is there sufficient evidence to reject the claim that the mean of yearly expenses is 1,500 tests at alpha equal to 0.05? Okay, when you put your questions, first identify the given information from the question. The first one given to you is your sample size. So n is equal to 50. Next, from this sample mean expenses, it is known that the given mean is x bar equal to Rm 1,300. Okay, and then your standard deviation, the sample standard deviation, then you know this is your S. Okay, this is your S, not sigma. Okay, this is your S. So Your S is RM 1100. What else? Your alpha is 0.05. Okay? Is there sufficient evidence to reject the claim that the mean of yearly expenses is RM 1500? That statement is your hint to develop your hypothesis statement. Now, look at the sentence that I underlined, and you can see the word is, right? So the word is reflect, okay, I'm dealing with population mean, and this is what we call the hypothesized value that is equal to 1500. And now, what does is mean here? Okay, so my mu naught is from the given hypothesized value. Then this sentence reflect that my null is mu is equal to my mu naught because the word is here. Okay, and what is my mu naught? My mu naught is equal to 1500. Okay, so this is what we can what we call interpret this sentence become this statement. Okay, so that's why in this case, if you look at your textbook, we have the first step will be your statement of hypothesis. Mu is equal to 1500, and the alternative, because you have your statement is to be tested, then automatically this becomes a two-tailed test. Okay, and which of the two is the claim? Based on this sentence, the claim is this one. Okay, so that's how we develop our hypothesis statement and identify what will be your claim. Okay, if you have any question, just stop me. Otherwise, I'll just continue. Okay, and the second step, you will need to what we call find the critical value. Critical value. So, what is the critical value coming from? How do we get it? It is depending on your alpha given in your equation. Since we are dealing with two-tail test, so two-tail test. Okay, so two-tail test means that this alpha will need to be divided by 2. Okay, so we know then my critical value is given by Z alpha over 2, which is Z 0.05 divided by 2, which is equal to Z 0.025. So look at your table of your standard normal. Okay, so for alpha 0.05, so you will get this value. Okay, 0.0257, 0.025. Okay, 0.025, that would be this one. Okay, 1.96. Okay, 1.96. Okay, 1.96. Now, since we know that we are dealing with two-tailed test, automatically your critical value will have two values. Okay, so that's why we have plus minus. Automatically, it will be plus minus 1.96 because we are dealing with two-tailed test. Now, next, third step. Find the test statistic. Okay, your test statistic is obtained by your Z, which is given by your X bar minus mu divided by, in this case, since sigma is unknown, okay, unknown, and our N is greater than 30, okay, N is greater than 30, so we are going to estimate, okay, based on our S. So that will be S divided by square root of N. So our X bar is 1300 minus the mu hypothesized, mu not here, is your 1500 divided by 1100 over square root of 50. In this case, we will get, okay, negative 1.286. Okay, so then we need to make decision. When we need to make decision, okay, make decision, okay, you will have to use your answer in your second step and the third step. So if I usually prefer to use the what we call the distribution so that you can discard them easily. Okay, since we are dealing with two-tailed test, okay, and this one is for alpha over 2, which is 0.025, and this one is alpha over 2, 0.025, and the value given by this critical value is negative 1.96, and we have positive 1.96. Now, our test statistic, okay, test statistic is given by negative 1.286. Negative 1.286, so we know that this is 0. 1.286, for example, if I put here, so this will be your Z test and Z statistic. Test statistic, that is Z equal to negative 1.286. Now we know that, okay, this is our non-rejection region. Okay, and this is our rejection region. Okay, this is our rejection region. The shaded red, rejection region. The same goes here. This is our rejection region. Now, since our test statistic falls in the non-rejection region, so what we do, we are going to make division that, okay, that our division here would be, since Z test falls in the non-rejection region, okay, so we fail to reject null hypothesis. Now, class, your decision will always reflect to your null hypothesis. Never ever say reject H1. Okay, reject the alternative hypothesis. That would be wrong. The one that need to be rejected or fail to be rejected will always reflect to your null statement. Okay, so we know then we fail to reject the null hypothesis, which means that our claim, okay, we fail to reject our claim because we don't have enough evidence to reject the claim. Okay, so that's why we make what we call our conclusion in such a way that, okay, so our conclusion would be, okay, there is insufficient evidence okay, there is insufficient evidence to reject the claim that the internet shopper spent RM 1,500 per year on the internet, okay, at 5% significant level. So this one is actually optional. You can start with, you can stop at here. So this one is an optional. Okay, so that's how we perform our hypothesis test. And for the first example, it will be a two-tailed test. Any questions so far, class? Any questions so far, class?
No, Doctor.
Are you all with me? Okay, no, eh? Okay, thank you. Now, if let's say I amend a bit the question, since I need to show you how you can deal with two-tailed test and how it becomes one-tailed test. If let's say I'm using the same questions and I change the question into a one-tailed test. For example, we are dealing with the left-tailed test. Okay. Now, all the sentences in the questions are the same except the last sentence. Okay. I change the last sentence. Become, is there sufficient evidence to reject the claim that the mean of yearly expenses, okay, is less than 1,500? I'm changing that into one tail test. Okay, so let's look how we can solve, okay, using the traditional method. Now, if I were to just very quick, okay, first step, the now statement, look at the last sentence. Okay, is there sufficient evidence to reject the claim that the mean yearly expense is less? So this is your keyword. Then if you have this keyword, that means it is stated in your alternative statement. So your mu will always be equal to, with the hypothesized value is 1,500, and the alternative would be mu is less than, so less than 1,500. Okay, so which of the two statements become your claim? Definitely based on the sentence, this will be true. Okay, so that would be the first one. Second step, okay, find the critical value. Critical value. So critical value is based on your alpha. So since this is one tail test, okay, and it is a left tail test, then Z alpha, which is Z 0.05. So Z 0.05, if you look at your standard normal table, 0.05, you will have 1.6449. 1.6449. Okay, so I have 1.6449. Okay, class. Should it be positive or should it be negative? Class?
Negative.
Negative, why? Why?
It's on the left side.
Yes, thank you. Correct. Left tail test. Since we are dealing with the left tail test, and definitely this automatically become negative. Okay. So the third step would be the same. That would be test statistic. Okay. So test statistic is using the Z, the same condition, unknown sigma, and then n is greater than 30. So Z is equal to mu x bar is 1,300 minus 1,500 divided by 1,100 divided by square root of 50. And this is again the same, that is negative 1.286. Okay, for decision, okay, so our decision would be, okay, our alpha for 0.05, so Z 0.05 negative is given by negative 1.6449. And your Z, our test statistic is negative 1.286. So negative 1.286 is somewhere over here. And we know that this is the non-rejection region. Okay, so again, we fail to reject the null hypothesis. So since you can write as, since Z test is greater than Z alpha 0.05, okay, negative, then we fail to reject the null hypothesis. Okay, so that would be your conclusion, decision. And for example, if we were to, last time the way we mark, so this will give you 1 mark, okay, this one will give you 1 mark, okay, this one will give you 2 mark, or maybe sometimes 1 mark, and this one will be 1 mark here, 1 mark here, okay. And then the last one is making the division, okay. So step number 5 is, making conclusion, okay. So since we fail to reject the null hypothesis, again, class, this time, it is a bit different because our claim now is at the alternative, okay. So when we have our claim at the alternative, okay, and yet we fail to reject the null hypothesis, okay. Remember, we fail to reject the null hypothesis, which means as if the null statement is what we assume to be correct. And since our claim is that it should be less than 1,500, so that's why we say we have insufficient evidence to support our claim. So the way we do the conclusion would be, okay, therefore, we have in okay, we have okay, we have insufficient evidence to support our claim that the internet shopper spend less than 1,000 RM 1,500 per year on the internet. Okay, here class, that will be the example if you have left tail test. What if you have right tail test? Okay, so let's say we skip the first, let's say the first step, it will be important because I want to show you how it becomes the right tail test. Okay, the first one would be your statement of your null and alternative statement. Your question is there sufficient evidence to reject the claim, okay, that the mean yearly expenses is more than 1,000? Okay, so your hypothesized value I changed to 1,000. So your mu is equal to 1,000. Okay, so 1,000, and then your alternative become mu is greater than 1,000. And automatically this will be your claim that needs to be supported. Okay, so your second one, okay, so your Z alpha, since we know our alpha is at 0.05, we know it is, what was the value just now? It's 1.6449. Okay, 1.6449. Since we are dealing with right tail test, so it will be positive. Right tail test. Okay, now the third one is test statistic. Okay, your test statistic will be the same. Okay, that will be a bit different, sorry. So it will be 1,300 minus 1,000 divided by 1,100 over square root of 50. And in this case, you will get 1.9285. Okay, so the fourth it will be decision. Okay, based on our step 2 and step 3, okay, we know that, okay, my critical value is at the that 0.05 is equal to 1.6449, which is this is the area of rejection. So this is the non-rejection region. Okay, so this is your alpha, okay, your rejection region. Okay, so and we know that our test statistic is 1.8928, sorry. Okay, so this is your test statistic. And where is the location of your test statistic? Let's say somewhere over here is your Z test. Okay, that is 1.928. So since it is falls in the rejection region, okay, so how do we decide? Since Z alpha Z 0.05 is less than Z test, okay, then we reject null hypothesis. Okay, so that would be your decision. And what would be your conclusion? Now, we are claiming that our mu is greater than 1000. And now we have evidence that we can reject null hypothesis, which means we have sufficient evidence to support our claim that the mean expenses is more than 1000. Okay, so therefore, okay, we have sufficient evidence to support our claim that the mean expenses the mean that the internet, okay, that the internet shoppers will spend more than 1000, okay, per year on the internet. Okay, so any questions so far, class? Any questions so far?
So far, no, Doctor.
No? Okay. Stop sharing for a while. I have shared the attendance link, so please who just joined the class, please fill the attendance link. So only half of you joined the class. Yeah? Really sad. Okay, so I continue with the content. Okay. Now, what's next to be covered? Now, we have finished with our first method, that is using our traditional method on how we can perform the hypothesis test. Now, what if we are using the p-value method, and how does the p-value method differ from what we have in the traditional method? Okay, so if you look back at the step in the traditional method, so hypothesis testing for p-value method reflect in the second, third, and fourth step. Because why? The test statistics still needed in your p-value method, but instead of the third step, finding the test statistic, we put that into your second step. So the second step will be finding the test statistic, that will be calculating your Z. If your n is greater than 30, and if your n is less than 30, then you need to calculate your p. Now, the third step will be compute your p-value. Okay, and this p-value is based on your test statistic that you have calculated in the second step. And then making decision is still the same at the fourth step, but then making decision will be based on the value of P as well as your alpha. Okay, let us look at the first example. Now, I repeat the first example, okay, using the same exact example of 3.6 so that you can compare and contrast how the traditional method and the what we call p-value method is done. Okay, so very quick, if let's say I rewrite the first step. So for the two-tailed test, would be now class. How do I find my p-value? Okay, my p-value will be depending on my test statistic that I got in my second step. Now, I know that this is my Z value, okay? And this will be my Z value, and I need to know what will be the probability. Yes, that will be my alpha. Sorry, my not to say my alpha. What will be the probability for this what particular shaded area here? So if we wish to find the what we call the probability of this shaded area, if we still remember when we deal with the continuous probability distribution, the way we find the probability value, we use the what we call symmetric understanding. So we are dealing with the same exact probability, for example, here, the one that we are looking for, okay? And this is the value of 1.2856. Now, how do I find this? Okay, so look at your what we call Z distribution. Okay, look at your Z distribution. Since we are looking for the value of this particular area, okay, so we are looking for this. Now, this is not the table that we need to help us out. So we need this because we have this value, which is 1.2856, right? 856. So since we are dealing with 2 decimal point, so approximate this become 1.29. Okay, so 1.29, what will the probability here? Okay, so we are looking for this one, but this one, 1.29, 1.29, okay, so we know that this one is 0.4015. So 4015, 4015. So we know that this is 4015, right? So this is the area for this particular probability. So I can write as this one is PZ between 0 and 1.29 is equal to 0.48015. So this one is obtained by, okay, so we will get this as 0.5 minus this particular area, so 0.4015. So you will get, what is the probability? Can someone calculate? So you will get 0.0985. Okay, now 0.0985 is reflecting what we call the probability here. Okay, so this is the probability of the shaded area. Now, for two-tailed test, in making decision, okay, so I write it using my red pen. For two-tailed test, okay, the way we make decision, okay, we know that, okay, if alpha is greater than p-value, so this is my p-value, okay, using my test statistic, I get my p-value, which is the probability here, okay, shaded in blue. Now, if alpha is greater than p-value, okay, means that, okay, I can imagine, never mind, because this is two-tailed test, I'm not going to confuse you. Okay. If alpha is greater than p-value, then reject null hypothesis. Okay, alpha is greater than p-value, then reject null hypothesis. If alpha is less than p-value, okay, fail to reject null hypothesis. Now, for two-tailed test, okay, you are going to multiply your p-value. Okay, so if you look at your textbook, okay, on the p-value method, okay, so you will see you will have to multiply 2 because we are dealing with left and right of your what we call tail. So 2 multiplied with 0.0985, you will get 0.197. Okay, okay, so here p-value, okay, is greater than your alpha. So what is our decision class? P-value is greater than alpha. So this is your decision. So fail to reject null hypothesis. Okay. So the conclusion and everything. Okay. So let's say I rewrite again. So this is your step 4 and step 5, the same as decision as above. Okay. As I just write as above. Okay. Conclusion. So any question here, class? So for two-tailed test, remember, multiply the p-value with 2, and then what we call, and compare with your alpha. Which one is greater than the alpha? Okay, so that would be two-tailed test. What if we are dealing with one-tailed test, which is much easier and easy for me to describe how we reject and we fail to reject the null hypothesis if we are having which of the value is greater than the other one. Okay, let's say for the second example, using p-value method is for right tail test. Okay, so the first one, the null hypothesis would be mu is equal to 1000, and alternative would be mu greater than 1000. Okay, so this is your claim. Okay, second, z-test or test statistic. So you will get 1300 minus 1000 divided by 1100 over square root of 50. So here you will get 1.9 something, 1.9285. Okay, number 3, p-value. So what is my p-value? So we are using our z-test. So we know that, let's say our z-test is somewhere over here. Okay, so this is 1.9 because we are using 2 decimal point, right? So 2, let's say 1.93. 1.93, we know the middle is 0. Okay, and using the first table, we know that we need to find what is the probability of this area from 0 until 1.93. Okay, so let us look at our back table. 1.93, 1.93. So, you get 0.4732. 0.4732. 4732. 0.4732. Okay, so what is my p-value here? So p-value equal to 0.5 minus 0.4732. So you will get what? Huh? Did you get? No one is calculating?
0.0268.
268. Okay. Okay, so now we know that this area is the probability is 0.0286. Okay, so now what is our alpha? Okay, our alpha just now I didn't write. So let's say I write the same here. So 0. Is greater than alpha is 0.0. Okay, here. Okay, now step number 4. Okay, decision. Okay, our p-value, okay, is 0.0268. Okay, with our alpha is 0.05, and definitely we know that alpha is greater than, so we reject. Null hypothesis. Reject null hypothesis. So I want to show you how does this become reject null hypothesis, because this now what is the area of my p-value? This is my p-value, okay, in the shaded blue. What is my location of my alpha? If I were to rewrite again, my alpha is somewhere over here. Because why? My alpha value is, the shaded red is alpha 0.05. Okay, so almost 2 times. So if you look again, what is my Z alpha? Z alpha, which is that 0.05, is equal to, what was the value just now? 0.05? 1.6449, right? 1.6449. So this is where 1.6449 is located. So obviously, if you are using traditional method, you are comparing this with this. Okay, but if you are using your p-value method, you are using the probability value in the rejection region and the p-value method. Okay, so that's how we make the decision if you are using your p-value method. Now, finally, the decision. Okay, conclusion. So as above. Okay, so look at the above. So that's all for the hypothesis testing for population mean. Before we move to the population conclusion, do you have anything to ask, class? Do you have anything to ask?
Doctor, can you scroll back
Yeah.
down?
Okay,
Yeah, to the question we just did.
last one. Okay, this one. Yeah.
Shouldn't we be sorry, what you call this? But supporting our claim?
In this case, we reject the null. So we reject the, as I mentioned, as above is, when I say as above, look for the same exact example for the right tail test. As above, not above, above of, I mean this question. Okay, means that using the p-value method, you are making the same decision, and of course your conclusion would be the same. So compare this to your p-value method. So this is where I need to you to refer to. As above refers to this one for the right tail test. Okay, not as above as, not meant as above means that as above this one is not as above as the same as this one. Okay, so look for example right tail test. Okay.
Oh, okay, I understand. Thank you, doctor.
Okay. Okay, thank you. So I think I should write, look for look for left tail test. This one is left, right? Two tail test. Look for two tail test. Okay. So if you don't have any questions, do you want me to do one example in the exercise question class? If you don't want, I just proceed with the proportion. Okay, you have exercise 3.4, exercise number 1 and number 2. Okay, let us do one example, one questions under your exercise. A researcher, so because we have much time, value exercise 3.4. Let's say number 2 seems a bit shorter. Now, a researcher claims that the mean time in seconds to pack all boxes with each box contain 20 bottles is more than 10 seconds. Okay? A sample of 30 boxes is randomly selected and it is found that X bar is equal to 11.6 seconds and S equal to 3.3 seconds. At alpha 0.05, is there evidence to support the claim? Use p-value method. Okay, this is a good question. Okay. Now, let us take out the information first before we can identify what will be our claim. Okay. So if you are dealing with n equal to 30, okay, and from this sample you get your x bar equal to 11.6, and you got your standard deviation of your sample is 3.3 seconds. Okay, and you need to use your alpha 0.05. Okay, so look at the first sentence. A researcher claims that the mean time in seconds to pack all boxes with each box contains 20 bottles is more than 10 seconds. Okay, so my question is, does 20 and 10, which of the which of the value means for the statement? Is it 20 or 10 that useful for your statement? Class. A researcher claims that the mean time in seconds to pack all boxes with each box contains 20 bottles is more than 10 seconds. So your statement refers to 20 or 10? Plus. Your statement refers to 20 or 10? Plus. Class. Mu is equal to what? Mu is equal to 10, right? Right. Plus. Okay. Mu is equal to 10. And in this case, the statement would be E is more than 10 seconds, so greater than 10. So this would be the claim. Okay. So second, find the critical value. So critical value is no longer useful because we are using the p-value method. So find the test statistic. So test statistic Z, because n is equal to 30. So we got the sufficient condition. Okay, so we will get x bar 11.6 minus mu naught, that would be 10 divided by the standard deviation, that would be 3.3 divided by square root of 30. Can someone calculate? What did you get here? What is the value? Can someone give me the value?
2.6556.
Okay, thank you. So that would be your test statistic. And the third one would be finding the p-value. So the p-value is using the exact test that you obtained in the second step. So you have 2.6. Let's say you're using 2 decimal point, 266. Okay, and we know that using the first table. Okay, so we need to find from 2.66, 2.66, 2.66. Okay, okay. 2.66. Okay, so you get 0.4961. 0.4961, 0.4961, so 0.4961. So my p-value here, p-value is equal to 0.5 minus 0.4961, which is equal to what? Is it correct? 0.0039? Is it correct? Okay.
Yes.
So, okay. Thank you. So, the fourth one, division. Okay. If we imagine using the alpha, so if my alpha is 0.05, which is larger than the p-value, means that my rejection region is larger than my p-value. So I can imagine that my rejection region would be located as this one. So since my p-value is inside my rejection region, so that's why we make division. Since okay, p-value is smaller than the alpha, which is p-value is 0.0039 and my alpha is 0.05, then reject the null hypothesis. Okay, so when we reject the null hypothesis, number 5, your conclusion. Okay, so do we have, so what was the claim just now? The claim is at the alternative statement, and we reject the claim, so we have sufficient evidence. So therefore, we we have sufficient evidence to support our claim that the mean time in second to pack all 20 bottles, to pack all boxes with each box, with each box contains 20 bottles is more than 10 seconds. Okay, so that will be your conclusion. So that's how we